Hello guys, thank you for connecting to my channel DevOps Corner. My name is Jean-Pierre Lugaba, and today I will be talking about Docker technology. So today you hear about Docker everywhere in your team, in software development. So they talk about Docker, and they talk also about what is called container application or containerized application. So what's the difference between Docker and the containerized application, and why we should use Docker uh, to in software development? So let's go on. First of all, before talking about Docker, let's see what is a containerized application or a container application. So a containerized application is an application packaged with all its dependencies and which runs in an isolated environment using a container technology. So a container technology like Docker or also other container technology like Podman. So here are the differences, the key differences between containerized application and traditional application. So first of all, for containerized application, uh, when they are packaged, so you have a package, an artifact that you can move and deploy everywhere on your local machine, on the cloud, on any environment. So you can deploy easily using that package. And we know that for traditional application, sometimes to deploy an application when an application is built, it is really tied to a specific operating system. So an application developed for Windows cannot work for macOS. That's an example. But for a container application, you can run that artifact everywhere on macOS system, on Linux system, on Windows system. Once you have that package. Secondly, um, inside that container, you have everything. You have the operating system, dependencies, libraries, and so on. Everything that your application needs to run. And while for traditional application, when you want to deploy a given application to your system, to your host, so you install it directly on the host operating system. So the host operating system will be used by all the application you deploy, which is different from containers. And then the container application brings this interesting feature of isolation. So when you deploy container application, they are isolated from other containers and even from the host processes. So this means a host can be an machine, a virtual machine, your laptop, your cloud server, so anything where you are running containers. So when you deploy container application, it's isolated from other running containers, and even from other host processes. And for traditional application, they share the host system or application you deploy, either on macOS, on Windows, on Linux. They share the system. And for a container application, they are really fast. So it's a matter of seconds. When you start a container, in 4 seconds, it will be up and running. For traditional, it's somehow slow, and it can even take more time. And then there is this feature of scalability that we hear about in the containerized application. So for containerized application, you can scale your application easily. using some orchestration tools like Kubernetes and Docker Swarm and so on. While on traditional application, it's really a complex process actually to scale an application. And the last feature is about a failure. Imagine when you are deploying on a traditional application on a system, when an application crash, then it will affect actually other application. Imagine the application crashes the OS or crashes some libraries which are being used by other application. So this means this failure will affect other running application. While on a containerized application, every container is isolated, and the crash of one container will not affect the remaining process, even the host processes. So the next topic now is Docker. So what is Docker? And so we understood that actually Docker is one one container technology. It's actually a platform for developing, shipping, and running container application. So it's one among many container engines which actually allow to manage container application. So this Docker will provide the ability actually to package an application, as I said, to run an application in an isolated environment called a container. So then this isolation actually also allows to run simultaneously many containers simultaneously on the same system, on the same host. As you can see here, I have multiple containers and they're running on the same host, which in Docker terms we call Docker hosts. So Docker host is a system, a virtual machine, your laptop, your cloud server, which actually runs Docker, and then on which we can deploy, as you can see, multiple containers. And then now we can ask ourselves a question: why using Docker instead of other container engines? So actually, every container engine has its own advantages and drawbacks. But for Docker, you have to know that Docker is a complete platform actually. It's a complete tool to manage the life cycle of your container application. So with Docker, you can build, you can deploy, you can share your application, you can do a lot of operations on your containers. So it's really a complete platform to manage applications. And then Docker, as I said, it's uh, it's fast. It's really fast to start container to even to stop them, and also it will provide this consistency across different platforms. If you are running your container on macOS, Windows, and so forth, so your container will work everywhere because it uses the same artifact. So Docker also can be integrated in what we call CI/CD process. So for those who don't know CI/CD process, it's either a DevOps process to build application, test application, and deliver application in companies. So Docker can be integrated well in this DevOps process, where local developers can can develop the application, package them into Docker, and then this Docker will go through a testing process using some CI/CD tools, and then if your application is tested, then it can go to production. So Docker can be integrated with the CI/CD process of actually of developing application and delivering application. And then why also you can use Docker? So we said first of all that Docker is fast and it's a complete platform. And the another feature is that Docker is scalable. So you can use Docker if you want to scale your application by using some orchestrators like Kubernetes. Actually, you can scale your instances, your Docker application, to handle the increase of traffic. So, which is a complex process for traditional application, as you have seen. So, and because of this, nature of Docker, which is fast and lightweight, actually you can deploy multiple containers on a same system with fewer resources. So you don't need actually a system with big resources to be able to run a container application. They are really lightweight and they are really fast. And on your laptop, you can deploy multiple container applications. So this is also one of the advantages of Docker. So before going further in Docker, let's talk about Docker image. What is Docker image and what is the difference between Docker image and Docker container? So a Docker image is a read-only template, a template with all instruction to create a Docker application. So this template contains everything needed actually to run an application. As I said before, the source code of your application, the runtime, libraries, and your application dependencies. So everything, as you can see, are really included in this image, in this artifact. So, and when you want to build an image, we do this later in our demonstration. So you need to start by a base image. So we need a base image. Let's take an example of a Debian image. And then on this image, I will install the Python if I want to actually to build a Python application. Then I'll deploy everything needed for Python, like the pip, the package manager for Python, and then I will also add my application requirements, and then all the dependencies, and even the source code of my application. So everything will be packaged in what is called my Docker image. And so this will be my image. So then what is the container? So a container is actually a learnable instance of my image or my Docker image. So after building my image, then I can use it to actually to start my container. So a container is an instance of an image. You run an image. You use to start a container. You need a specific image of your application. So and as you have seen, containers run in an isolated as isolated processes on a host machine, and they use the kernel technology, two technologies. The one is the namespaces, and the other one is the C groups. So those are the kernel features actually of operating system, which allows actually to for namespaces, it allows actually to limit what the process can see. This means like what my container will be able to see, like the network, like the process ID, the PID, like the mount, mounting, the volume mounts, and so forth. So this will limit actually my container to specific networking, to specific features actually. And then the C group, which is called a control group. So it will limit my container on how much my container can use in terms of CPU, memory, and so forth. So the C groups limits my processes on how much they can use in terms of CPU, memory, bandwidth, network bandwidth, and so forth. While namespace, they limit, they isolate container actually, and they allow only containers to access specific network interface and specific volumes, and so on and so on and so forth. Um, so now let's talk about the Docker architecture. So in Docker, actually, we have a lot of components. So we talked about the Docker image, Docker container, Docker hosts, but also you have other components which are really important to know when you are using Docker. So the first component, as you can see, is the Docker daemon. So Docker daemon is like a basic, a fundamental component of Docker. So it is the one that implements all the API that are needed to run container, to build Docker image, to retrieve image if they are stored on a remote registries and so on. So Docker runs in a client-server architecture where we have a Docker client, which is called Docker, and you have a Docker server. I can call it Docker server or Docker daemon, which is called Docker D. So it's Docker daemon. It's the one that implements our API, and that's actually the one that does our heavy operations. And the Docker client will call this daemon actually to request some operations like to run, to start container, run the command docker run if you want to start a container. If you want to build an image, then you do docker build. So those are the Docker client, which is requesting the Docker daemon to do those operations. And then, as I said, Docker host can be any system, physical machine, a virtualized machine, your laptop, a cloud server, which runs Docker, which runs Docker components. The third part is the registry. So the registry will be actually the store, which is used actually to store the Docker images. So imagine you build your image and you want to share this with your team. So you push this image to Docker registry. And this Docker registry then will host your image, and you can pull that image whenever you want from different places. And so that's really the architecture of Docker. And as I said, we need all those components to work really with Docker. So when talking about Docker registry, we have some public registries, and the one which is known, which is most known, is the Docker Hub. So Docker Hub is a public registry that anyone can use. So you can push your image there, build your image there. You can share the image with Docker communities, and so on and so forth. But also, there exist some private registries. If you are, working in your company, you need a private registry where you will store your image. Your image artifacts, and this can be in your on-premise environment on your private cloud, and this can be also on a public cloud. So we have some managed Docker registries like on AWS. There is what is known as Amazon Elastic Container Registry. On Azure, also you have managed container registry. If you want to host your image there, there is what is known as Azure Container Registry, and also on other cloud providers. So those are the components of Docker, and those are really important components we need to know before going in deep and use Docker. So next step we'll be talking about will be the first demo, and the first demo will be about installing Docker on your system. So let's do it. Hello guys. So welcome back to my channel DevOps Corner. So let's proceed with Docker installation on my system. So let me switch to my server. So guys, as you can see, I have a server, um, which is a virtual machine running in the cloud on Microsoft Azure, which is a public cloud for Microsoft. So let me switch to root user. I'm now root, so I have all necessary privileges. So let's check my system. It is this. So as you can see, I'm running Ubuntu and 24.04 release. So you can use your laptop. You can use any virtual machine running somewhere in the cloud, or even your physical machine. So it will work for any machine. So let's proceed with the installation. So we'll be following the official Docker documentation on how we can install Docker on any system. So let me proceed with you. Okay, as you can see, I'm connected to the official Docker website, docs.docker.com. So let's go and get started, and then we go to get Docker. After this, we scroll down, and you can see actually Docker Desktop for Mac, Docker Desktop for Windows, Docker Desktop for Linux. So you can choose and the Docker Desktop depending on your system. If you are using a laptop for Mac, you can go with this. So if you are using Windows, you choose the second, and so on and so forth. And Docker Desktop actually is a version of Docker which runs actually on a desktop system, and it contains everything needed for Docker, every component. And in addition to that, there is a dashboard, actually a graphical dashboard, where you can which you can use actually to do directly installation, to run Docker commands, to run your container, and so on and so forth. So go on and choose your desktop. I mean your version, depending on your system. So for me, I will go with this option. I will install actually Docker Engine because I'm using a server. So let's proceed. Yes, and you can see the list of supported platforms. So I will choose Ubuntu. Then I will go down and I will follow these installation methods. As you can see, installation methods. And for us, we use this install using apt repository. So apt repository actually is the package manager for Debian distribution, including Ubuntu. So I follow this step. So we have like two steps. So we set up Docker apt repository. I mean, we configure the repository for Docker, and then after we install our necessary Docker packages. So you will follow this with me. I will do actually an installation from scratch. So I will run this command to uninstall to uninstall everything, and then to start the installation from scratch. So now let's switch to my server and follow me with the installation. Perfect. So let's start. Okay. So I will uninstall everything. So for you, if it's the first time to install Docker, so you don't really need to uninstall Docker, so you can start directly with the installation procedure. So now I think everything's okay, and I can go further and uninstall everything to actually to do the installation from scratch. So let me uninstall everything. Okay, great. And let me do some remove some further. Yes, and let me remove also the repository for Docker. Okay, great. So my system, guys, is clean. If I run Docker version to see if Docker is installed, then you can see Docker is not known actually. So as you can see, Docker not found, command not found. So great. So you should see the same if you don't have Docker. So let's proceed with the installation. Perfect. So let's copy the procedure. I will start by updating my system. So apt update. So it's okay. So we will be installing uh, some packages, some certificates, and some commands. So let's run this. Okay. So let me copy again the command because I was mistaken. So let's install the certificates and car command. So it's okay. So let me proceed with the installation of, creation of killings. So killings folder where the repository keys will be stored, and also after I will download the key for Docker the repository, and I will configure the correct permission on this key. So let's proceed. So after this step, I will run another command actually, which will um, add the Docker repository in my apt sources. So let's proceed with this. So this command, okay. Perfect. So this command, actually what it will do, it will um, add the Docker repository to my sources. So it will, first of all, check my OS release, my distribution, and so on. And then after it will configure the correct, apt repository source. So let's run the command. Okay, so guys, this is okay. So to check if the repository was added to my apt sources, we can do a cat of this file, and then you can see if the repository is there. Okay, great. So you can see there is this Docker repository which is added to my apt sources with the correct key. As you can see, the correct key that we downloaded before. So now, then let's again update my system after the repository configuration. Perfect. So my system is updated. So now we can now go to the second step and install Docker packages. Okay, perfect. So I'll be installing Docker Community Edition, Docker CE, and also Docker Client and the Containerization.io, which is also another container engine on which Docker is based, and also Docker Compose, which is another Docker client actually, which is used to manage multi-container application. I mean a container which runs multiple containers. So sorry, an application that runs multiple containers. So this can be used, can be managed by Docker Composer, and we have a demo on this also. So let's install all necessary packages. Yes. Let's wait a little bit. Okay, perfect. So now everything is supposed to be okay. Huh? So let's check if Docker is present on my system by running Docker version command. Okay, perfect, guys. As you can see, I have Docker, which is installed on my system with the version 28.1.1. So what else? Let's also check if the Docker daemon, if you remember Docker daemon component, which should also be running on my system. So let's check this. We use systemctl status docker. Okay, perfect. So the Docker application container engine is running since 50 seconds ago, and you can see that it is the daemon. Initialization was completed, and it is listening for API on this socket. So guys, everything's okay now. So Docker is running on our system. We can start using Docker. So I will do one last command. One last command, Docker info. So info just to view all information regarding Docker client and Docker server. So let's see this. Okay, so client Docker engine community. So this is the client. This is the version for our Docker client. And this is the server information. So as you can see, we don't have any container on our server. No running container. and you have zero image, so it's normal. Have zero image, and this is the server version. And you can also see the C group driver, which is systemd. So the C group is the control group driver, which will be used by Docker actually to limit our containers on how much resources to use in terms of CPU, memory usage, and so on. So we saw this before in my presentation. And what else you can see? You can see the Docker host information. I mean, the server on which Docker is running. You can see the kernel version. So this is the version for my virtual machine. This is the operating system. This is the OS type, and this is the architecture, of course. This is the CPU, and this is the memory. So you can see I'm having the server of two CPUs and almost 8 GB of memory. So this is my host name of my server, as you can see. So guys, everything's okay. You can start now using Docker, as you can see. And now let's switch to the second demo, where we run our first Docker container. So thank you. Let's switch to the second demo. Hello guys. So welcome back to my channel, DevOps Corner. So in this demo, I will be installing our first Docker container. So my previous demo one, I installed Docker on my system. So in the second demo, let's now start our first Docker container. So let me switch to my server. Okay, as you can see, I'm connected to my server, and we have already Docker installed. Sorry, we have already Docker. So Docker version. So great, we have our Docker here. So now let's start our first container. So to start a container, as we said, we need an image. We need a Docker image, which is a template which contains every information about the container. I mean, the operating system, the libraries, the application configuration, the source code of our application, and so on and so forth. So we will install a simple container, an Nginx container. So an Nginx container, if you are not familiar with Nginx, is a web server, a most known web server, and also a reverse proxy. I mean, for web application. So we'll be installing this. And the first step is to get the image. So we'll be pulling the image from the Docker Hub. So if you can remember, the Docker Hub is the public registry. Is the public registry on the internet, where you can find almost, the images shared by the Docker community, and you can use also this for your project, for your own development, for testing purpose. So we will be pulling an image from this Docker Hub. So let me, a little bit before proceeding, show you show you Docker Hub, so that you can know Docker Hub, what I'm talking about. So let's type Docker Hub. It's Docker, sorry, Docker Hub. So as you can see, this is the registry. Sorry, perfect. So this is the Docker Hub website. So the public registry where the Docker images are stored. And let's look for Nginx image. So I will type image, Nginx image. So let's search for this. And I will look for the official Nginx image. Okay, as you can see, this is the Nginx official Docker image from the Nginx team. And here's the command if you want to pull this image and use this image on your system. So guys, I will be using this procedure. So I will pull, first of all, this image on my system using docker pull command. And so let me switch to my server, and then I will pull this image. So let me run this command, docker. First of all, let's check if you have an image. So as you can see, docker image command to see if you have images on our system. So as you can see, I have no image. So the list is empty. So let's now pull this image, Nginx, docker pull Nginx. So this image will be pulled. Let's wait for that. Okay, so it's now complete. So now if I run again the command doc image to list my Docker image on my system, sorry, as you can see, I have now the image. So the Nginx, and this is the size. So it was created 4 weeks ago, and this is the image ID. The image ID. So there is also what is known as a tag. So a tag, guys, is actually it's like a version for our Docker image. So when we build Docker image, we give them some tags to actually to precise the version. So it's either latest, or it can have another version, version 2, version 1, and so on. So you can tag also according to the platform. You can tag image, for instance, dev, or production, or another environment staging, and so on. So to actually to know where the image is used. So now we have our Docker image on the system. So now we can start the Docker container. So we start the Nginx container. So to run a container, there is a command which is docker run. So to start a container, and then we can precise the name of our container. So let's say my Nginx container, and then I will add another parameter which is -d. So this means detached mode. So we are actually running the Docker in the background. So we don't want the container to run actually to be started in the terminal. So we need this process to run in the background. So we add this option -d detached, and then I will also add another flag which is -p. So -p is an important flag actually to expose the container process, I mean container application on my server. So the container will be accessed on my server. So I will do the port forwarding. So let me write this. So I will expose the port 80 of my container to be actually exposed on my server, on my virtual machine on this port. So to access my Nginx web server, I can use directly my host, my server network IP, and directly on this port, I will be be able to access my container application. So it's a port forwarding, which will be done by Docker to actually to expose my Docker container on my server network. After this, I will then precise the image to use. So the image, as you have seen, is the Nginx image. So I'm starting my container. This is the name. And then in the attached mode, so this is the port forwarding. So I will expose the port 80 of my container to my host on port 82. And then this is the image the container will use to run. So guys, let's run the command. Okay, so the container is started. So now let's check if our container is started. So we run a command called docker ps. So it's process show. We show all running containers on my system. So as you can see, I have a container running. This is the container ID. This is the image used by this container. And it was created 21 seconds ago. And this is the port forwarding, actually, as you can see. And this is the name of my container. So there's a container ID and a container, how can I call a container name. So my container is running, guys. What I can do is to access actually my web server, my Nginx web server in the browser. So I will share my browser and I will access actually this container using my machine, my server IP on the port 80. So first of all, you can use localhost if you are using your laptop, or yeah, localhost actually to access in the browser, to access your container in the browser. If you are running your server somewhere in the cloud or on on a premises environment, then you can use the server IP. So guys, let me look for my server IP. So I think my public IP, I can find it like this, if config.me. Actually, if you're running your server has a public IP, you can get an IP like this. So as you can see, I have this public IP, so I will use this. Then let's switch to my browser and show you and access my server. So HTTP. Perfect. Okay, guys, as you can see now, I have my Nginx container running here on port 80 or using my public IP of my virtual machine. So guys, everything now is okay. Now we have our container, which is started, and everything is okay now. So guys, let's switch to the next demo, where we will try to actually to interact with our running container. We'll try to actually to enter our container using the shell terminal. We actually open a shell terminal in our container and we try to debug to interact with our running container. So let's go on. Hello guys, welcome back to my DevOps corner channel. So in this demo, number three, I will be talking about Docker, and we will be actually interacting with our running container. So in my previous demo, we started a container. So we deployed our first container. So we used Nginx image to start our container. So now it's time now to interact with our running container. So guys, let me switch to my server and let's start. So perfect. So now let me start. Actually, as you can see, we have an Nginx running container. So let's check this. So Docker PS to show our running containers on my system. So we have a running container. So how can we interact with it? So it's quite simple. So we open a shell in our container, uh, like what you do on your laptop or what you do on your server. You open an SSH terminal. I mean, you open a shell terminal on your server using SSH or PowerShell or and so on. On your Mac, you use a terminal. So we do the same with our container. So let me, so to open a shell inside a container, so we run the command docker exec. Then we put the interactive mode and so minus IT. Actually, minus IT, we allocate a TTY terminal, and I is to have the interactive mode, and then we specify our container name. So my Nginx container, and then after I precise which shell I want to use. So I use bin bash. So I open this bin bash, I mean shell inside my container. So guys, let's run this command to see if we gain the access to the container. Perfect. So as you can see now, I'm inside my container. So I'm no longer connected. Actually, I'm inside the container, as you can see here, and I'm root. So what can I show you? Maybe let's run the command hostname. So this is the hostname for my container. So what else can I check? Let me check. So this is actually the file and folder in my home, in my root folder, in my root user home deal. As you can see, you have a lot of file here. So remember, this is the Nginx app container. So now what you can do actually is to go and maybe display the configuration of our Nginx web server. So so let's cat the etc slash nginx and nginx configuration. So this is the main nginx configuration file. As you can see now, we can check the configuration. So we are running the default configuration. So this is the worker connection. And what else? So this is the keep alive timeout. So this is the configuration for our Nginx web server. And also what you can do is to go in the root directory. I mean, where the HTML configuration is stored. I mean, to the web root further. So we can enter the web root. It's user share Nginx. And inside this folder, you can see HTML folder. Inside the HTML folder, you can see, our index.html for file actually, which is the one we displayed in the previous demo. So yeah, so that's it. As you can see, we can interact actually with our running container, and we can do also. Let's, for instance, change this file. Let's I don't know if so this editor is not installed. So let's install, for instance, a package. So I can do a update to update the system. So as you can see, I can run some commands as I can do on my virtual machine. So let's do apt install this editor, which is called Vim. Yeah, great. So I'm installing this package Vim inside my Nginx container. So perfect. So then now try to open the Nginx, the index file in my editor. So this is the index, the default index, HTML index file for the Nginx. So let me modify this, add something to see that, to show you that you can actually interact with a container, install packages, modify everything. So let me add a new line here, a new paragraph. Insert mode. So I'll be insert mode. Let me add a new paragraph. I will say, hey, we running Docker. Okay, perfect. And then I will cross my paragraph tag. Okay, perfect. So let me store this index file. So now we modified the Nginx default file, default index file. So now we can I can switch to my browser and to see if the content has changed. So this is something we can do. So let me switch to the browser. As you can see, I switch to my browser and let's refresh our page. Okay, perfect. So as you can see now, I have, hey, we are running Docker. So as you can see, guys, I I entered my container, my running container, and I was able to modify some file and also to install some packages and so on. So you can interact with your running container using by opening a shell inside that container. So guys, now everything's okay. Now I'm inside the container. So if you want to leave this, you can exit. So run the command exit. And now you will be back to your machine, your virtual machine or your laptop. Terminal. So now, sorry, I'm back to my server, and I'm no longer inside my container, and my container is still running. So I can run docker ps, and you can see my container is still running. So guys, now let's switch to the next demo and still actually connected. Hello guys, welcome back to my channel, DevOps Corner. So now we are on demo number 4, and we will be performing basic operations on Docker containers. So on previous demo, demo number 3, we interacted with our running container. by opening a shell inside the container, and we did some changes on actually in our running container. So today, let's switch to this demo where we perform different operations on our container. So guys, let me switch to my server and let's start. Okay, perfect. So guys, now I'm on my server and let's check if I have running container. So perfect. So in my previous video, actually, my previous demo, I talked about interacting with our running container. So we can use either container name or container ID. So we used container name, but we can use also container ID to actually to open a shell inside our running container. So we can, for instance, do docker exec, as we said, interactive mode, and then we precise our container ID, and then we specify which actually shell to use. So as you can see now, I'm inside my container. So I'm inside my container, and as you can see, I used the container ID. So you can use either container ID or container name. So perfect, that's great. So let me exit from my container. Perfect. So guys, now we perform some operations on my running container, and the first operation you can do is to stop a running container. So how to stop? So we run the command docker. Let me first of all show the container docker ps. So now let me stop now this running container. So let's do this docker stop, and then we specify the docker stop, and we specify either the container name or container ID, but I recommend you to use the container ID. So let's use the container ID. So now our container actually is stopped. So let's check if our container is stopped. Docker ps. So guys, as you can see, our container is not listed in the running container. So now how can we see if our container is stopped? So we can list the stopped containers. So there's a command now called docker ps. Then we add a flag -a, which means all containers. So here we are listing all containers, including running and even stopped containers, exited containers. So let's run this command. And as you can see, docker ps -a, then we have our container nginx, but which is actually, you can check the status, which is exited. So exited, so this means it's not still running. So it is stopped actually. So this is how to stop a Docker container, Docker stop. And now we can go on even and delete our container. So we just do Docker delete. So let's do it. Sorry, let's do this. Docker to delete a Docker image. So let me first of all show the stopped container. Perfect. So we run the command docker rm. So to remove actually the container, we run the command docker rm. So docker rm, so to remove, and then I will specify the ID. And then let's run the command. So if I display again all containers, As you can see, we no longer have a container either running or stopped. So we deleted everything. So remember, it's not Docker delete, it's Docker rm. So Docker remove. Okay, perfect, guys. So now let's uh, go to another operation which is interesting. So now we know how to start a container. We know how to stop a container. We know also how to delete completely a running container. Now let's now see how to actually to commit changes to a running container. So to do this, let me first of all start our container. So let's start our container. I will run the same command we did previously. So let me get the command we used. Then docker run. So I want to get the command we used to run the Docker. So let me use this Docker run. Okay, perfect. So now let me type this command. So we will start again our Nginx container. Perfect. So it's started, and you can display our running container. Okay, great. So now let's go to actually to our container, and we will make some changes. We will maybe modify some configuration file. We install some additional packages and so on. So, and what if we want to actually to create a new image from a running container? So we did our changes, main changes to our running container, and we want to create a new image, a new Docker image, which will be used later and which includes actually our changes. Because what you have to know is that when I delete the container, then all data will be deleted. So if I did changes, then all changes will disappear. And when I start again a new container, then I will not get the all changes, because actually we are starting a container from an image, from a template. So if we need to do a change, to do some changes, we need to do changes in our image. So we need to create a new image, which includes our changes. So let's do this. Let's connect to our container. Yes, we open a shell inside our container. Perfect. And let's, for instance, install a package, update the system, and let's install a package which was not there. So I will run apt install vim, for instance, which is an editor. Okay, so this package is installed. Okay, perfect. So I can go on and modify also some file inside my container, like my Nginx configuration. So let's go there. It's user share Nginx HTML. So this is the web root folder which contain our HTML content. So this is the index file, HTML index file, and let's do some changes. So let me add something. Maybe let me add again. Sorry, let me add another another paragraph, and I will say, hey, we are updating our running container. So I will close now my tag. Okay, perfect. So now I updated my configuration. I installed a new package. And what if I want next time when I start my container to have those changes? So I need to commit those changes to a new image. I need to create a new image which will then contain all those changes. So that next time when I want to start a new container, then it will have those changes. So that's what we will do. So I will exit from my image, my container, which is still running, as you can see, Docker PS. So it is running, perfect. And then let me commit the changes to a new image. So I create a new image. So and the command to commit changes and to a new image is docker commit. So I will specify which container I need to create the image from. So this is my container, as you can see. And then I will create a new image, Docker image, which will contain all the changes. So let me call this my Nginx version. Let me call it updated. So let me call this my Nginx updated. So I will call this will be the name of my image, my Nginx updated. So let's run the command. Okay, perfect. So this means actually that we created a new image which contains all the changes from our running container. So let me show this. Let me display our image on my system. And as you can see, I have the already Nginx image that we have pulled from Docker. And as you can see, I have a new image, which is my Nginx updated, which was created 21 seconds ago. And this is the size. So now we have a new image, and as you can see, we have the increased size. So this means we did some stuff inside, and the size, of course, was increased. So this is normal. And if you want, we can now start a new image using a new container, using this image. So let me start a new container using this image. I can do this, docker run. The name will be my updated, my updated container. And then I will specify detached mods if I want to, but yeah, detached mod. And then I will specify my image. So my image which will be used will be this new image. Okay, perfect. So let's run our container. Okay, perfect. So Docker PS. As you can see now, you have two running container. This one, the new container, and this one is the old container. So as you can see, I didn't expose the port to my server for this container. And now let's actually open a shell inside my container, my new container. Docker exec -it. Then I specify the container ID. Then I specify which shell to use. Perfect. So now I'm inside my new container, which is updated. And let's display the HTML page. So to display the HTML page, I can actually get the page on localhost inside my container, car HTML localhost, and then in verbose mode. And as you can see, I am displaying my HTML page, and you can see, let's see if you can see the changes we added. Yes. So as you can see, there's a new paragraph, which is called we are updating our running container. So this means we are running a new image, which actually which have all the changes we made to the previous image. So guys, this is interesting. We updated our previous image, and then we created, our previous container, and then we created an image from the container. So we can create an image from a running container. So this is perfect. So let's exit. And so guys, those were the basic actually operation we can do with Docker. And I think now you know almost, I mean, not every command, but the important commands when you are using Docker. So now let's close by here this demo, and let's switch to the next demo. Hello guys, welcome back to my channel DevOps Corner. So in this demo, demo number 5, I will be talking about Docker volumes. So we'll be actually creating Docker volumes and using them actually inside our container. So let's now start this demo. But before starting, I want to tell you about Docker volume. What is Docker volume actually? So Docker volumes. So let me first of all go to the official Docker website. So as you can see, I'm sharing the official actual documentation of Docker. So Docker volume actually are data store for containers. So if you want to persist data for your container, then you need to use volumes. And those volumes are created and managed by Docker. So, and simple to create a volume. So, as I said in the previous demo, when you were working with containers, so when you delete a container, you will lost the data that the container created. So the way to persist this data even after the container deletion is actually to use volumes. So we will attach volumes to our container, and the volume actually will be our store for our data store for our container. Even though the container crashes, or even if the container is deleted, then we'll still get our data, because our data will be actually stored externally to our container. Actually, as you can see, our data will be stored on Docker host machine. So the machine which hosts the containers. Then this is where our volume will be created. And the volumes actually are files in our directories actually, and files actually in the Docker host file system. So if I'm using my virtual machine, then when Docker create a volume will be actually a folder on my file system. So on my Docker host file system, on my virtual machine file system. So if you're using your laptop, then a volume will be a folder on your laptop, somewhere on your laptop. And then all the container data actually will be stored there. And what is interesting with volume is that you can mount that volume inside a container, and you can even mount this inside multiple containers. So multiple container can share a VM, can actually have access to the same data. And also, if a container crashes, you can start a new container, and this container will be also access that the data on that volume. So that's the volume overview. And now let's switch to actually to my server, and we will create a volume, and we will mount this volume inside our container. We will start a container with this volume attached, so that actually the data can be persisted even after the container deletion or if our container crashes. Okay, guys, so let's start. So now you have access to my, you can see my server. Okay, perfect. And now I will be creating a volume. So first of all, let me see if I have some running container. Yeah, I have many running containers. So let me first of all delete all those containers. So I will run the command docker rm, and we then okay. Okay guys, this is interesting. If you want to remove running containers, you will see an error. As you can see, error response from daemon. Cannot remove container. Container is running. Stop the container before removing or force remove. Okay, so if you remove the running container, there will be an error. You have first to stop the container and then delete the container. Or you can force. So what I will add normally is a force. So when I add this option force, then I will force the deletion of running containers. So if I show docker ps -a, so you can see I have no running container. So now that is perfect. We are going to start this from scratch. Okay, I will start by creating my volume. So let's do docker volume create, and I will say my uh, my data store, my data store. Okay. Okay, let's use this. I say container data store. Container data store. Okay, perfect. So my volume is created. So if I display docker volume and say ls, sorry, docker volume ls. So it is saying docker and then command docker volumes. Okay. So I think I can use docker volume like this. Okay. So there is no s on volume. So it's docker volume ls just to display my my volumes. Okay, as you can see, I have this volume created. And let's see some details of this volume before using this. I will run docker volume inspect. So you want to see some details of your volume or even details of your image. There is this inspect command for Docker, actually to display the details for the Docker objects. So Docker volume inspect, and then I will give the volume name. So let's see the information on our volume. As you can see, it was created this date, and I want you to see this mount point, var lib docker volume container data store data. So this is a folder actually on my virtual machine on my Docker host machine. So this is where actually all the data will be stored. So the container will use this volume as an external data store, and every data of the container actually will be stored in this external store. So that's what I wanted to show you, that the volume is actually a folder on my file system. Okay, perfect, guys. So let's now start our container using this volume, and we actually mount this volume. So let me create a container as usual. I will use Nginx container. So let me start this docker run, then name. I will run my Nginx container. Okay, perfect. Then in the dash mod, then I will mount the volume. So it's minus V to mount a volume. And I will specify the name of my volume. So this is the name of my volume, which is actually a folder on my file system. And then I will precise actually the place inside my container where I need to mount this volume. So this means I have a volume here, and there is a mount point inside my container where I will mount this volume. So let's specify, for instance, the Nginx webroot folder. So it's user slash user, sorry, user, then share, then Nginx slash HTML. So you are now familiar with this. And then after, I will specify the image, which will be used to run the container. Okay, perfect, guys. So as you can see now, I'm starting a container, and I'm actually mounting this external volume, and I'm mounting this inside my container in this folder. So this means every Nginx configuration, I mean the web HTML file, will be automatically be stored actually inside my volume. So let's run this command. Okay, perfect. So I have my Docker container created, as you can see. And this is the volume which is mounted actually inside the container. So guys, now let us check something. Let's go to the um, to the file system where this volume is created. So the volume is created inside my Docker host machine in this folder. Var thinglib docker and volumes. Okay, so all volumes will be created in this folder. And now let me do ls. So when I do ls, as you can see, there is a folder called container data store. Container data store. Great. And there is this data folder underscore data store. Perfect. And guys, what can we see? As you can see, we have files here. We have indexed HTML file, and we have this file too. So where those files are coming from? So those files are the file from our running containers. Our running container. So our Nginx container, which is running, is storing their data in this file on my virtual machine. So as you can see, so if I delete even the container, I stop the container or I delete completely the container, then I will still have this data because the volume will not be deleted. So unless I delete the volume. So when I delete the volume too, then the data will, of course, disappear from this folder. And even this folder will be deleted. But when I delete only the container, then this volume will stay. And this volume can be mounted later on another container. So, guys, that's what we are going to do. So I'm going to delete this container. Docker rm, and I will delete my container, and the name for my container is this one. So let me delete this, and I will force the delete. As you remember, I need to force because if I delete the running container without stopping it, then there is an error. So, okay, guys, I don't have a running container, as you can see. So, no container. So, but I still have the volume. So, if I check Docker volumes, ls, so then my volume is still there. And the Nginx container stored the volume here, the data here. So, I can see the data. And so, let's go to go back to the Docker volume, the folder where Docker stored the volume, and let's check if we can still see the HTML file. So let's see. So guys, you can see. Can you see? We have our file, even though the container was deleted, but the data of the container was persisted. Actually, the HTML content data was persisted inside this file system, inside this volume. And we can start another container and use this data and mount this volume. So, guys, this is perfect. And as you can see, so this means actually we can create a container and persist their data. So every data the container will create, either the logs, the configuration, the states, and so on. So those data, we can persist them outside on our Docker host machine, so that we can keep this data even though the container is deleted or the container crashes. Okay, so thank you guys. Now we can close this demo, and now let's go to the next demo. So thank you. Hello guys, welcome back to my channel DevOps Corner. So I will be talking about building a custom Docker image. So we build our custom Docker image. So in the previous demo, the demo number 5, we have worked actually on the Docker volume, how we can use Docker volume to persist the container data. So in this video now, we are talking about building our Docker image from scratch. Okay, so guys, let me share my terminal, my server, and let's start. Okay, perfect. So guys, as you can see my server. So I don't have a running container. So now let's build an image from scratch. And then we run a container from our customized image. So we will be building a simple Python application. A simple Python application which will simply print, um, which will print uh, error word or simply error docker. So error docker. Okay, that's what I'm going to do. So let's first of all create our application, our Python application, a simple Python application. So I will create a file app app so dot Python, and in this file I will actually put some a simple Python code. So I will define my main function, and then which will print the word error docker, as you can see. Okay, it's just simple. Okay, perfect. And what we do is, okay, we save our file. Then we will also create another file, another optional file, just to which will be our application dependency file. So in Python, if you've created Python application, you need a file called requirements. So we will create this requirements file, requirements.txt, which will contain actually a dependence, some Python module needed by our application. So normally we don't need this in our application, but I will add this requirement. Yeah, I will add this to be part of our container. So now we have our the request module. So for those who are not familiar with Python, so this is a module for Python responsible for doing some HTTP requests. So this is an example of dependency for our application. So let's now save our file. So we have now our application source code app.python, and then you have our requirements file, which contains our dependencies, our dependencies. So this can be an application and any dependency. Maybe you are working with Java with Node.js, so you can have your Node JS application. Can have your dependencies, your package JSON dependencies in Node.js, and so on and so forth. So it will be the same process actually, and then we will create an important file which is called a Docker file. Actually, in to to build a Docker image, we need this file which is called Docker file, which will contain actually all the instruction to create our image. So all instruction will be defined in this file, and this will be an important file actually which Docker will actually read to see which instruction, and so that Docker can build your image. So let's go on and create our Docker file. So I will create a Docker file. As you can see, Docker file, Docker file like this. Okay, perfect. Then let's put all the instruction for creating our container, then our image, sorry, then I will explain a little bit every line. So let's explain every line to understand actually the instruction to create our image. So first of all, As I said before, in my presentations before, actually, when we want to build a Docker image, we actually use a base image. So we build our image from another existing image. And in this uh, image, actually in this Python image, we will first of all use a Python image, a 3.9 stream Python image available on Docker Hub. So Docker Hub is the public registry which stores the public images. I mean, if you want to share the image with Docker community, then you publish your image there. So we use this as base image, and we use this keyword from, and then we specify the base image actually we use. And as you can see, as we are building a Python application, we are using a base image of Python, of course. So we not need to install Python in our image. Python will be already installed. So some packages will be already available in our image, like pip, the Python actually manager, package manager will be already there. So what we'll do later is just to add our application. So the next steps are steps for actually creating our application and adding our application configuration and our application dependencies. So after we define our working directory, I mean workspace. So a Docker image needs a workspace to know in which workspace, in which folder actually the the configuration are located. So we use this keyword workdir, and we say is this slash app. So in this slash, this will be created. It's actually a directory which will be created, and all configuration of our application will be inside this folder. So we set the working directory, and then after we copy our requirements file. So you remember the requirements file that we created. So we are copying this from our machine, and then we are copying this inside the image. In the so this point means actually we are copying this inside the container in the working this. So after copying this requirements text, sorry, the requirement file, then we will run this command inside our image, of course, to install the dependencies. So the dependencies which are defined in this file will then be installed using pip, the Python package manager. So after installing the package, I mean the dependencies modules, then as you can see, we will copy our application source code. So you remember we created this file, app.python, which contains our application source code. So we copy this inside our image in the home directory. And then after, we can do other stuffs like defining some environment variables. So if your application needs environment variables, so then you can create an environment variable called app-env production. So this means we are running the application in a production environment. And then the last, step is to define the CMD. So the CMD keyword actually defines which command will be run by Docker to start your application. So to start your container application, if you need to start the container from this image, which command will be run actually? And this is the command. So the command will be Python and then our our source code, so app, then the application will be started. So we have a list of instructions, and those are not only the keywords that exist, there exist a lot of keywords. So you should actually you should go and check the official Docker documentation. You will see a lot of keywords actually you can use. So those are the basics. The from to specify the base image, the workd to specify the working directory, the workspace actually, where all the application configuration will be located inside the container. And then the remaining step are for, copying the dependencies, installing the dependencies, then copying the application source code, setting variables, and so on and so forth. So now we have uh, our Docker file configuration. So let's save this file. So now we have our Docker file ready. So now the next step is to build our image. So we are now going to create this image. So to create an image, we run the command which is called docker build, and then we specify the image. So what is the image? What is the name of the image which will be created from our docker build command? So we precise this T, uh, which means tag, but as you can see, we will precise the name of our image. So let's call our image my Python app. Yes, my Python app. And then I will add a tag. So if I don't add a tag, then it will take the latest tag. So let's not add a tag. So it will take the latest tag. And then I precise Docker build. Then I precise the name of my image, which will be created. So if you want to tag the image to get like a first version, you can do like this. So this is the name of the image which will be created, and this will be the version 1. If you put nothing, then it will take latest as the tag of the image. Okay, then after we will put dot. So a dot, what the dot means actually? So the dot means that Docker will find for Docker file inside, uh, the workspace where actually we are running this command. So we are running this command from the root folder of my virtual machine. So this means Docker will go and look for Docker file to build this image. So this dot means where the Docker will look for the Docker file. So it will look for Docker file in my current directory. So let's now run the command to build our image. So the build process started. As you can see, there's a lot of steps. As you can see, there's a lot of steps. So first of all, as you can see, Docker will check the definition from a Docker file. After Docker will pull the metadata from this image. So this is the Docker Hub image. As you can see, this is my base image I'm using to build the image. So this is the base image. So Docker will go and read all the metadata. So we load this image. And then after, as you can see, those are what you call Docker layers. So those are image layers, as you can see, which will be retrieved from the base image. So after Docker will start building my image. So as you can see, it will define the working directory. It will copy the requirements as mentioned actually in the Docker file. It will run pip install to install the dependencies. It will copy my application source code, and then the image will be ready. So as you can see, my image will be created and will be named actually what my Python app v1. So this is the process to build your own Docker image. And let's see if our image is available in on my local machine. Docker image. Okay, guys, as you can see, I have my Python app image with v1 as tag. So this means this was created a minute ago. So this means actually the uh, process to build an image was worked actually. So that's great. That's perfect. So what we can do now that you have an image, we can run our container. Use actually we can start our Python application. So let's do it. So I will run Docker run, and then I will specify my image. So my image is, if you remember, is my Python app. Then I specify the tag, which is tag v1. Because as you remember, if I don't precise the tag, then it will take latest tag, and it's not good because my image has v1 as tag. So let's run this command, guys. And as you can see, I'm not running the image in detached mode, so I want the image to run in the console. Okay, perfect. So guys, let's see the output. As you can see, the output is this, the error Docker. Error Docker. So this is what our Python application is doing. Actually, is it's printing out the word error Docker. So guys, uh, our image was built, and as you can see, we are able to start our container. So, and this is what the image should, our container should print actually, as you can see in our application source code. Our application should print this word error Docker. So perfect, guys. We have a running container, Docker PS. Sorry. So our container printed actually this the word hello Docker and then exited. So because actually we don't, as you can see, exited. So this the process actually. So our image actually prints the word hello Docker and then it exits. So and this worked perfectly. So guys, thank you for watching this uh, demo. So we have built our Docker image, our Python application, and after building our image, then we started a container using the same image. So thank you guys, and see you in the next demo. Hello guys, welcome back to my channel, DevOps Corner. So I'm now going to talk about working with Docker Compose. So in our previous demo, we saw actually how you can build our custom Docker image. So we have built our Docker image, Python Docker image, a simple Python Docker image, and we were able to run this container, and everything was great. So let's now switch to the demo number 7, which is the latest actually. This will be the last demo in this series of Docker wraps. So I hope also that you enjoy this. Okay, thank you. So what is Docker Compose and why we should use Docker Compose? In which context we should use Docker Compose? So first of all, Docker Compose is a tool which helps actually to manage a multi-application container. So an application which runs multiple containers. So you can see this example. We will be building actually an application like this, my app, which is made of three components. The first component which will be the database, and the other component will be the front end, so the front end part of our application. Then we have the middleware, which is the backend, actually, which we implement the logic part of our application. I mean the API and so on and so forth. So there is also another file you can see how which is called Docker Compose YAML file. So this will be the application which will define, um, I mean, all our application configuration and also the dependencies for our application. And so you have time to see this. So let me switch fast to the official documentation actually of Docker Compose, and we can see what really it means. So as you can see, Docker Compose is a tool for defining and running multi-container applications. So if you want to define an application made of multiple containers and you want to run this application, then Docker Compose is your best choice. I mean, when you are really working with Docker, because you have also some orchestrators, which maybe I will talk about in the next, video, like Kubernetes and so on. But when you are using Docker, simply Docker, then if you need to run a multi-container application, instead of running each container independently, then you can define the application using Docker Compose and then run the entire application using also Docker Compose. So as you can see, Docker Compose will simplify the, um, the control on your entire application stack, and it will be it will be easier to manage services, network, and volumes in a single YAML file. So here you have really a single YAML file, which will define your entire application stack, and you will manage the life cycle of your application using this file. So you can start the entire application with one command. By running one command, you can stop your entire application using this one command, and also check the running services. So this is perfect. So guys, let's now switch to my server, and then let's start implementing this. Okay, perfect. So first of all, we will start by checking if Docker Compose is installed on my system. So guys, you have to know that if you are using Docker for desktop on your laptop, then Docker Compose is already included. So you have to do nothing. So you have already Docker Compose. Yes, so that's it. You have already Docker Compose. So what am I going to do now? Let me check in my system if Docker Compose is there. So I will run Docker Compose version to check the version. So as you can see, no such file or directory. So it seems I don't have Docker Compose. You can see this. So now let me install this. So I will install this using the apt actually command for which is used for Debian. So apt install docker compose. Okay, let's run this command. Okay, perfect. So now let me see if Docker Compose is now present. Okay, perfect. So I have Docker Compose now, which is deployed now to my system. So I can now start working with um, Docker Compose. That's perfect. So guys, now we are going to build our application. So as you can see, I have no running container and I have no image on my system. So no image, no running container. So we really do the demo from scratch. Perfect. So let me show you the structure of our application, which we need actually to define with Docker Compose. So you can see here, this is really our application, as you can see. So we try to create this folder, my app, and inside this app we define our components. As you can see, we have three components: database, front-end, middleware. And this is what is known as a three-tier application. So a three-tier application is really an application like this, which is made by multiple components. And we are going to define this with Docker Compose, and we run this with Docker Compose. So keep in mind this structure, this application structure. So thank you. Let's switch back to my terminal. Okay, perfect. So let me now start by creating the structure. It's important to know this structure. Okay, so I will create first of all um, my app folder. Okay, perfect. So I have my app folder, which is here. And then inside my app folder, I will create now three components. I will create front end. I will create middleware, which is the backend, our backend component. I will create database, which will be running our database. So this will be, I will use PostgreSQL database. Okay, so now that's fine now. So we have now how I'm gonna say, you have our structure now, as you can see. So we now let's go to every component now and define our application, our container application. So let's start by the front end. So in the front end, so we use an Nginx web application. So our application will be running Nginx. So what we need to do, first of all, as we saw in the previous demo, if you want to build a container application, I mean an image for our application, so we need to define a file called Docker file. So a Docker file. So let me create the Docker file inside a Docker file for our front end application. Okay. Sorry, it's not a directory. It is a file. So let me remove this. So it's not a folder, but a file. So I will directly open this Docker file and I will actually insert what we should do. So what we should do is, first of all, we will, build our image. And the first command is to precise which base image will be used actually to build our image. So we use Nginx official image as our base image for our application. And then we actually copy our customized index file to override the default index HTML file. So we just do a simple stuff. So we don't need this demo to do complex operation, but you understand when you are building a production ready application, you may do a lot of step here. But in our case, I will just copy an index file which I have customized to go and override the default indexed HTML file. So no, this is okay now. So I have everything needed for my Docker file. Let's do this. Yes. So we have Docker file now. Then I have to create this index HTML file. So I will create an index HTML file, which will be actually override the default HTML file. So let me HTML create this, and then inside let me create a simple h1 h1 tag, and let me call this hey. Sorry, let's work with Docker Compose. Okay, perfect. So I have my customized index HTML file. Perfect. So we keep this simple. Okay, so let me save this. Perfect. So in our front end, we have a Docker file, and we have our index HTML file, which override actually the default index file for Nginx. Perfect. So we have everything needed now for our front end. So we have everything. So now let's switch to the middleware. So middleware will be our backend. So our backend will be a Python application, which we run. We use Flask to, the Python framework, which is called Flask, to actually to run our backend. So let's now start by the Docker file. Yeah, so create a Docker file. So let's create a Docker file for our backend image. So in our backend image, this is what we do. So as you can see, we use as base image Python 3.9 Docker image, which is available on Docker app. So we pull this image as our base image, and then we add additional configuration for our app. We define the work deal, and then we copy the requirements text. So you remember the requirement text, which is a file containing all dependencies for our application. So in this file, we have Flask module, Python module as our dependency. And then we will run this command pip install actually to install this dependency of our application before running our application. So then we copy other components, other remaining components to our workdeal folder. And then after, this is the cmd is the command which is used to start our application. So that's perfect. So everything's okay. So now this application.python will be copied actually in this step. This step we copy this our source code, and then we also put our source code inside the work deal. Okay, perfect. So the Docker file is ready. Let's now create. So let's start by our application, our source code. Okay, so here's our source code. So this will be app Python, and let me paste this here. As you can see, we are importing Flask module, and we are defining this application. So we have this endpoint, which is the root endpoint, the slash, and when this endpoint is called, then it will return error word, error from Flask. Sorry, error from Flask. Okay, perfect. So yeah, and then we will run our application, start our application. So as you can see, it's a simple Flask application. So that's great. So let's now create our dependency file. So the file which will contain um, our dependence, our module. So this is requirements.txt, requirements.txt. Perfect. So let's now put our requirement. So there is this Flask module, and I will put the latest version. So 3.1.1, I guess. Yeah, I guess this is the latest. Yes, this is the latest test one. So this is the version of this Flask module which will be installed actually while building our middleware image. So perfect. It's okay now for our middleware. So let's go and now define our database component. So we'll do the same. So we create the Docker file for our database. So the file needed actually to define to contain the instruction for building our image. So in this Docker file for our database, then I will put this information. So let's see the details. So we are using the Postgres SQL database, Postgres SQL database. So we are putting this image from Docker app. This will be our base image to build our database image. And then we'll set some environment variables like the user and password, and also which database will be used. And then finally, we copy this init.sql file, which contains actually some SQL commands actually to initialize our database. So, so this is the initialization script actually, which will create our database, create the user, a password, and then create the table needed, and so on and so forth. So now we have now our Docker file for creating our database image. So let's save this. And then after I have to create this script, this initialization script, which will be used to initialize our PostgreSQL database. So let's do this in init.sql. Okay, so as you can see, we create a table called my table, and then we define some fields for this table. So ID and a name. And also, yeah, and it's all actually. So this will create a table, a simple table in our database. Okay, perfect. So now we have how can I say? So now we have, I think, everything needed for our components. So let's now check the current structure now of our application. So let me here. If I run the command 3, so as you can see, we have the database component, front-end component, middleware component, Docker file in every component, and some configuration file. Okay, this is perfect. So guys, we are ready, but it remains only one file. So one file is remaining. So this file is the YAML file, which defines our entire application. So what we defined here are components, but we need to have one file, which by default it is called Docker Compose YAML file, which will define our different components, the build folder, the folder which will be used actually to build the image, and also the services to run. So the services to run, so every component will run a service, and also the order of execution. So this means if you want to start your application, you have dependency components dependence. So like you will, for instance, choose to start first of all the database, and the front end will need to be able to start. We need, for instance, the middleware to be started, and the middleware to start, we need the database to be running. So you understand this dependency between components. So this means in this YAML file, Docker Compose, it's really where we define all components dependencies and the order of execution. Okay, perfect. So let's create this file. So this will be called, and as you can see, this file is on my directory, my app, inside my directory, my app, on the root, just on the root, as you can see. So I will create directly my Docker Compose file, Docker Compose, then YAML. Okay, perfect. And then inside, I will define this, and then I'll explain what it means. Okay, guys. So this is my Docker Compose YAML file, as you can see, and here are the services defined inside this. So I have my front-end service. So this is the build folder. So to build this image, it will go to this folder. As you know, this is where we defined the configuration for the front end. And then it will run after build, then it will run this and expose the 8 port of the application to the 80 port of the node. And this is the dependency I was talking about. So this means to start front-end service, the middleware service needs to be started fast. And the same for middleware. So to start middleware, the database should be started fast. And database doesn't have any dependency, so it will start fast. So Docker Compose will manage this order. And as you can see, we have also other configuration. So we expose every service on our Docker host machine and to a specific port from the middleware, even for the database. So this is not, I think, this is not recommended for production environment, but for test purpose, you can do this. Okay, so guys, we also create a variable called Postgre data. Sorry, and this Postgre data is a variable which will be created by Docker Compose to store the data, the database data actually to an external storage. So if you are running a database as a container, you need to store this data so that if the database crashes, you can still retrieve your data stored in an external database. So we now use Docker volume. So we have seen this in our previous demo, how to work with to create volumes and make persistent external storage for our running containers. So guys, I think we have everything now. So what I can do is to save this, and we can now run our application stack. So let me once again run this command 3, and now I will show you all. So as you can see now, we have the complete structure of our multi container application. So let's now start this. So to start this, guys, so I can go back here simply. Can go back here, or I can go inside my app, no problem. And what I can do here is to run the command docker compose. So what you're going to do is we're going to build first of all our image, our application images. So you have multiple images which will be built, and then also we will start our application. So let's first of all build. So now we build the image, and then we'll start also our containers. So let's do this. Let's run this command, docker compose app. So app is for running containers. So when you want to run all containers of an application, you just do docker compose app. And what we do, we add this component, this flag called the build. So this means we're going to build the image, and after we are going to start containers. And what I want to add also is d minus d in the detached mode. So I want the containers to be started, but to run in the background. So let's guys run our command. So let's wait. So it is building the image. As you can see, the front end part is being built. And also, and this, what I was talking about, so this is following the order defined actually in Docker Compose. So Docker Compose started building the database. And when this was finished, it then it's so then the middleware part followed, as you can see. After this middleware part, there is now the front end, which is being which was built and started on the last time, as you can see. And as you can see down here, we have our 3 components. We have our database part, which was done, middleware part, which was done, and we have our front-end part, which was done. So our application was built and started. So let's now check if everything is okay. So to check with Docker Compose the running services, we run the command docker compose ps. So perfect. Docker compose ps. As you can see, we can see we have database, front end, middleware, and they are app, guys. So our services are app. So every service is app, and those are the ports the application is using. So everything's okay now. And if you want, you can even check this with Docker, because Docker Compose will use actually Docker to start those containers. So if you do even Docker PS, you should find normally those running containers. As you can see, we have containers. And guys, those containers are running those images. So those images are the image we built actually with Docker Compose. So first of all, we built the image, and after we started the containers using those images. So as you can see, guys, everything's perfect. And I think the last part I can do is to show you the front end part. So as you can see, we have a front end. So let's see this in the browser to see if how can I say, to see if our front end is running, guys. So let me do this. So I will look for the IP. So I think I remember the IP for my yes, the IP is this one. So let's run this. Okay, guys, perfect. So as you can see, we have our front end which is running. Let's work with Docker Compose, and this is our customized configuration, and this is not the default configuration of Nginx. So, guys, this is perfect. As you can see, we have managed to build our multi-container application, and to start this with Docker Compose, and to check the running services using Docker Compose. And now, if you want to stop the running services, you can do it with also Docker Compose. Simply, you can do Docker Compose, and you put down Docker Compose down, and this will stop all running services. So this will take some time, guys, and you can see now. So the services are stopped, and this is done. And also to remove the network. So this is the Docker network, which is used actually by those containers. So it will also be deleted. And if we do Docker Compose PS, guys, you will see nothing now. Okay, nothing. So this means we have stopped our running application. So guys, I think everything was okay now in this demo. And I think you have enjoyed my video. So this is the last demo for this Docker series, and I hope you enjoyed. So don't forget to subscribe and to like, and also to comment, and just put in the description if you have enjoyed my video, and if you want why not more videos like this. So guys, thank you and see you next time. Bye bye.